Hi, and welcome to Carol Henry and Josh Klein's Winter 2020 quarterly update on regulation devices.
At a high level, our project hopes to overcome the challenge of improving SIG meetings through in the moment regulation. But in order to understand what this challenge really is, you need to know what SIG meetings are and what we mean by regulation. Starting off with SIG meetings are weekly meetings focused on planning among members of the same SIG. SIGs, or special interest groups, are made of undergraduate mentees and a grad student mentor who are all working on projects in a similar domain. Ideally, SIG meetings follow the three-step process listed here. A mentee talks about last week to give context for what learning their project needs to get this week in order to advance, as well as a high-level overview of how they intend to get that learning. Finally, a mentee will go over their sprint plans, which detail more of the tasks involved with their plans. A challenge in our project is that mentors and mentees' goals for SIG meetings are in conflict with each other. Mentees want general feedback and validation on what they have done and intend to do. Mentors want to use SIG as a time to teach students how to think about their problems so they can make plans accordingly. This is why they want to avoid giving direct feedback and validation. Instead, they want to scaffold students so they learn how to think through this. Now, that covers the SIG part of our challenge. Next is the regulation part. When we say regulation, we mean the ability to control and direct one's behavior so they can meet certain standards, achieve certain goals, or reach certain ideals. Regulation is a process. One must identify a goal they want to achieve, they must then monitor their self in relation to that goal, and then finally they need to determine if their current state is their goal state, or if they need to change their behavior to reach that goal if they have not reached the goal state yet. In SIG, this awareness of one's current state is difficult because mentors and mentees are already juggling a lot on their minds. Mentors must process what the mentees are saying, find holes in their logic, and figure out a way to deliver a response that isn't direct in order to make a teaching moment out of it. Mentees are trying to extract the tangible next steps from what the mentors are saying, but they can only do this once they have learned whatever concept the mentor is trying to teach in that moment. With this overarching challenge in mind, we began our quarter. You can divide this quarter up into 4 parts as seen here. We first conducted some need finding, wrote out arguments concerning the design situation and our prototype. We then made that prototype and then conducted a short study to use our prototype to test the arguments we had made earlier. As I just mentioned, the first phase of this quarter was need finding. We started off interviewing mentors because we had been very focused on the students' problems in past quarters. A risk in our project was that SIG in our interventions involved both mentors and mentees, but we had been focusing much more on mentees and had much less information on mentors. We therefore we needed to take a step back to better understand the goals and challenges of mentors, so we conducted interviews with 4 mentors at the beginning of this quarter. After conducting those interviews, we then did some qualitative coding. We went through the transcriptions of our interviews and highlighted quotes to find themes in what was said across the multiple interviews we conducted. Amongst these themes, we found many different goals and many different obstacles. Having groups of text didn't let us see the relationship really between these different quotes pertaining to obstacles and goals, or they didn't even let us see relationships amongst those goals and obstacles in general. Mapping the relationships between these goals and these obstacles let us determine which ones were the most important to tackle and how they related to each other. With this knowledge, we could identify the most important outcomes and obstacles to center our arguments and prototype around. The design arguments summarized our most important outcomes, related obstacles, and introduce our conceptual approach to solving the problem and the characteristics. Our first argument focuses on what it means for mentors to teach students how to plan better. Better in this case refers to recognizing and diagnosing their risks, connecting their sprint stories to those risks, and relating deliverables to the Canvas or end of quarter goals. Both of our obstacles have to do with not being able to get all 3 planning skills accomplished in one meeting. The first concerns being unaware of how much time has passed because mentors and mentees have a lot on their minds, as explained earlier. The second concerns getting stuck on a relatively unimportant topic because a mentee poorly articulates something they wish to say, so mentors end up giving a lot of feedback based on that poor articulation. To overcome these obstacles, we want to promote awareness of what is being prioritized during SIG and help scaffold students' articulation so that they can efficiently and effectively explain themselves.
Mentors want to be able to help their students achieve long-term skill development, which requires practice across many SIGs, but current SIG tools don't explicitly emphasize a student's skill development. This combined with time on awareness and prioritization of short-term practical needs often leads to some skills unintentionally not being practiced in the meeting, because later stages of the expert thinking model aren't discussed. The lack of skill tracking and lack of time awareness makes it difficult to recognize what skills need help the most in the moment and how much time they have left to practice their skills.
To realize the outcomes and characteristics of our design arguments, we developed a prototype with 3 components. We created a scaffolded agenda for students to complete before SIG instead of the normal planning view tab of their Canvas. Next, we introduced a reflection period during SIG for both the mentor and mentee to participate in. Finally, the skill tracker was a tool we developed for mentors to also use during SIG. Our interface and system arguments explain why we believe each component would be successful. The agenda's purpose is to scaffold articulation so certain items get brought up and others are communicated clearly in SIG meetings. One challenge we anticipated is that some students, especially those new to DTR, might have trouble communicating clearly because they are trying to talk about concepts they haven't learned yet. This is why we decided to structure our agenda according to expert thinking model. It helps break down planning into steps, but in using the expert thinking model, we were introducing new concepts to students. That's why we included scaffolds to define these concepts, along with questions and examples to help students better understand them as they filled out the agenda. This is what the agenda looked like. There are 2 tabs, one to have students think through last week's plans and another for this upcoming week's plans. The columns represent phases of the expert thinking model, and scaffolds, as seen to the right, help students fill in each of these columns. To promote awareness of what topics and skills are being prioritized during SIG, we introduced a reflection period. 5 minutes before the end of SIG, mentors and mentees would be able to reflect upon what they had discussed during this time. They'd have the agenda to see what topics remain, to determine which has the highest priority, so they can then spend the remaining time on this topic.
For the skill tracker, mentors need to be able to identify and mark what skill was just worked on, so they can easily see what skills have been worked on and use that information to help prioritize and work on those skills. However, it's not always clear in the moment what skill was practiced without reflection because of the cognitive burden mentors already have during SIG from their conversations with their students. So, we need a minimum list of skills to allow easy scanovers in the moment, as well as a custom input option for mentors to make the skills more applicable to their students. Here's an example of the skill tracker after one of our tests. When a mentor identifies a skill was practiced, they hit the complete button and can see the distribution of skills practiced during that SIG, getting a better understanding of what they worked on and why and what they maybe didn't. When mentors are able to track what skill development they have worked on during SIG, they can use that information to structure how they provide feedback and prioritize what they discuss in SIG, such that in the long term they work on all the skills necessary. This prototype doesn't push for all these skills to be practiced in one SIG, but rather ensures that they are all given attention throughout a period of mentor-student meetings. We conducted a study across 5 SIG teams with 6 students and 4 mentors. The purpose of this study was to find evidence that supported or broke our arguments such that we can make them stronger. Specifically, we had 4 hypotheses that we wanted to test.
We had 3 core findings related to our first hypothesis. The first core finding comes from new students. They had plans that were aligned with their risks because they are able to think more conceptually about their problem and solution by relating things back to the canvas. In terms of our design arguments, this relates to the teaching outcome. In the agenda, students could recognize and diagnose their risks on a more conceptual level, connect their plans to these more conceptual risks, and did so by relating things to the canvas. Our interface characteristic was to have scaffolds that make abstract concepts more concrete in order for mentees to improve their articulation, and that's what we found in how they filled out the agenda. Students found the definitions of the expert thinking model phases to be too abstract to know if their plans actually corresponded to the phases. The questions and examples in the scaffolds allowed them to check what they had written down, ensuring it was well articulated because it actually fit into the appropriate expert model phase. The last finding we had related to our first hypothesis was that students were confused on how to use the agenda in SIG. There was too much information there to know what to say. Should they go over everything they wrote down? Should they give a high level? Do they do one risk to completion and then move on to a second risk if they had that written down as well? While plans were well articulated in the agenda, this did not translate to them being communicated clearly in SIG because students didn't know what parts of the agenda they should actually say during SIG. Moving on to our second hypothesis, we had 2 core findings. The first is that new students don't come into SIG with a lot of questions because they don't find value in risk assessing their plans because they anticipate that those plans will change when problems and questions naturally come up during the work week. Because of this belief, Our agenda and its scaffolds weren't helpful in having new students identify questions before SIG, let alone communicate those concerns during SIG. The second core finding concerning our second hypothesis is that students were hesitant to put down questions when we first tried to have them correlate questions with phases of the expert thinking model. Students weren't quite sure where in the model the questions were supposed to go and didn't put them down because they felt uncomfortable with potentially getting things wrong. Like last time, because questions weren't written in the questions and concerns sections of our agenda didn't ensure that certain items got brought up, let alone were communicated clearly during SIG.
For our third hypothesis, we were testing whether mentors were aware of the skills being practiced in SIG and using that to help them. We found that after SIG, mentors were able to reflect on the skills their students practiced and adjust how they might provide feedback for the next SIG. This information supported our design argument outcomes as mentors became more aware of long-term skills while still dealing with practical needs. We also uncovered another obstacle because we did not understand the cognitive burden of identifying skills that the mentors had. For our fourth hypothesis, we wanted to test our students and mentors using the reflection periods, how they use the reflection periods to prioritize the rest of SIG. We found that mentors often use this period to analyze how time was spent and what to discuss next, weighing various factors. This supported our design argument of bringing up issues that might not previously have been brought up before. However, this break near the end of SIG wasn't enough to get mentors and students unstuck from certain conversations. A major limitation we faced this quarter was the brief testing period we had for our prototype and arguments. Not only does practice with the prototype help our users get more comfortable with it, but some of our arguments relied on long-term analysis. We sliced our arguments and prototypes to test what we could with limited time, but it would have been nice to have multiple testing iterations with the same users to see longer-term effects. Although Carol and I are not continuing next quarter, there are a couple things we would have liked to continue and expand on. First, we would conduct a longer-term study to start analyzing whether our long-term arguments were supported or not. Also, after our testing this quarter, we identified some areas for improvement for our prototype and technology. For our agenda, a structure needs to be added such that students can better communicate their risks, work, plans, and concerns at the beginning without overloading their mentor or skipping details. As for the skill tracker, technology improvements could greatly reduce the cognitive burden for mentors. We imagine a system that would suggest what skill was potentially just practiced, and then the mentor can mark how well they did it. This lets the mentor focus on the conversation with their students while also getting a more granular understanding of the skills their student is exhibiting. Through need finding, argumentation, prototyping, and studies, we have some major takeaways from this quarter. First, from our testing, we are starting to see signs of in-the-moment regulation. Using the agenda, reflection periods, and skill tracker, mentors and students are starting to reflect on their goals and adjusting their actions during SIG to reach them with guidance from our prototype. While there are still plenty of challenges, we see these prototypes and arguments as moving in the right direction. For next quarter, were we to be working on this project, we would continue our study and continue to make the technology improvements for the agenda and the skill tracker. However, because a new team is taking on this project, we suggest to them to read through our arguments and study to better understand what we have learned and what we are trying to accomplish. Thank you.